Time is the DNA of reality. It is a cosmic code, written into the very fabric of existence, dictating the unfolding of stars, galaxies, and life itself. Every moment is a single letter in this grand, sprawling narrative. This story began with a single, explosive point of unimaginable energy. We call it the Big Bang. It was not an explosion in space, but an explosion space. Before this moment, there was no here, no there, no then, and no now. All the matter and energy, all the laws of physics that govern our universe, were contained within a point smaller than a single atom. It was the ultimate beginning, the first word in the epic poem of the cosmos. From that initial burst of pure light and energy, the universe began its relentless expansion. It was a chaotic, searingly hot soup of fundamental particles. As it expanded, it cooled. This cooling allowed quarks to clump together, forming the first protons and neutrons. For hundreds of thousands of years, the universe was a dense, foggy plasma, trapping light within it. Then, a great transition occurred. The universe cooled enough for electrons to be captured by atomic nuclei, forming the first stable atoms of hydrogen and helium. For the first time, light was set free to travel across the vast, expanding darkness. This ancient light, the cosmic microwave background, is still visible today, a fossil echo of the universe's infancy. This primordial story is not just something that happened long ago. It is happening now, all around us and within us. The atoms in your body, the iron in your blood, the calcium in your bones, were forged in the fiery hearts of stars that lived and died billions of years ago. We are, in the most literal sense, stardust. We are the universe made conscious, capable of looking back at our own origins. We are a way for the cosmos to know itself. This journey through time, from a single point of light to the complex world we inhabit today, is our story. It is the story of how everything came to be, and it connects us to the grandest scales of space and time. Our quest to understand this cosmic code is one of humanity's greatest adventures. We build vast telescopes to peer into the distant past, catching light from galaxies that existed billions of years ago. We construct powerful particle accelerators to recreate the conditions of the early universe for a fleeting moment. Every discovery, every new piece of data, adds another chapter to our understanding of this immense and beautiful story. We are time travelers, using the tools of science to journey back to the very dawn of creation. And as we look back, we also look forward, wondering what the next lines in this cosmic code will spell out for our future. After the first light broke through the cosmic fog, the universe entered a long, dark age. It was a vast, quiet expanse of hydrogen and helium gas, slowly swirling under the gentle pull of gravity. But gravity is patient and persistent. Over millions of years, it gathered these simple gases into enormous clouds. As these clouds grew denser, their cores became hotter and hotter. Eventually, the pressure and temperature became so extreme that they ignited the fires of nuclear fusion. The first stars were born, lighting up the cosmos like a string of celestial diamonds. These first-generation stars were massive, hundreds of times larger than our own sun, and they burned through their fuel in a cosmic blink of an eye. These giant stars were the universe's first great factories. In their blazing cores, they fused simple hydrogen and helium atoms into heavier elements. Media group, stellar nucleosynthesis in core, heavy elements forming inside stars. Star core fusion processes stock and distribute equally carbon, oxygen, nitrogen, and iron. When these massive stars reached the end of their short lives, they didn't just fade away, they exploded in spectacular supernovae, scattering these newly forged elements across the cosmos. This stardust became the raw material for the next generation of stars and planets. Our galaxy, the Milky Way, formed from these enriched clouds of gas and dust. Within it, countless new stars ignited, including a rather ordinary, medium-sized star we call the Sun, born about 4.6 billion years ago. Around our young sun, a spinning disk of leftover gas and dust began to coalesce. Dust grains stuck together, forming pebbles, which grew into boulders, and eventually into planetesimals. Through countless collisions and gravitational tugs, these bodies formed the planets of our solar system. Among them was a rocky world at just the right distance from the sun. It was not too hot, and not too cold. It was a Goldilocks planet we now call Earth. In its early days, Earth was a violent, molten world, bombarded by asteroids and comets. But these very collisions delivered a precious cargo: media group, comet delivering water to Earth, ancient oceans forming under volcanic sky, water filling early Earth basins, stock and distribute equally, water, which filled the first oceans under a thick volcanic atmosphere. In these warm, shallow, primordial seas, something truly miraculous happened. Simple chemical compounds, energized by lightning and ultraviolet radiation, began to form more complex molecules. Over hundreds of millions of years, these molecules organized themselves into self-replicating structures. Life had begun. The first living things were simple, single-celled organisms. For billions of years, they were the sole inhabitants of our planet, slowly transforming its atmosphere by releasing oxygen as a byproduct of photosynthesis. This great oxidation event was a catastrophe for early life, but it paved the way for a new, more complex biology to emerge, one that would eventually lead to us. For most of Earth's history, life remained simple, but evolution is a powerful engine of creativity. Through natural selection, life diversified into a breathtaking array of forms. About 6 million years ago, in the savannas of Africa, a new branch on the tree of life began to grow. A species of ape began to walk upright on 2 legs. This simple change had profound consequences. It freed the hands for carrying tools, food, and infants. It allowed these early hominins to see over the tall grass, spotting both predators and prey. This was the first giant leap for humankind, a physical adaptation that set the stage for the evolution of our most powerful tool, our mind. Over the next few million years, the brains of these early humans began to grow dramatically in size and complexity. With bigger brains came better tools. First came simple choppers made from river stones, used for butchering animals. Then came finely crafted hand axes, spears, and eventually, the control of fire. Fire was a game changer. It provided warmth against the cold, protection from nocturnal predators, and a way to cook food, making it easier to digest and unlocking more nutrients. This extra energy may have fueled the continued growth of our energy-hungry brains. Fire also brought us together, creating a social hearth where stories could be told and knowledge could be passed down. Our species, Iwar, emerged in Africa around 300,000 years ago. We were not alone. Other human species like the Neanderthals shared the planet with us. But we had a unique advantage, a sophisticated capacity for symbolic thought and complex language. This allowed us to cooperate in large groups, to plan for the future, and to build a shared culture. Around 70,000 years ago, we began to migrate out of Africa, spreading across every continent on Earth. We adapted to frozen ice ages, dense jungles, and arid deserts. We were the ultimate survivors, using our ingenuity to thrive in any environment. This cognitive revolution was the true birth of humanity as we know it. For tens of thousands of years, we lived as hunter-gatherers in small, nomadic bands. Our lives were intimately connected to the rhythms of nature, but around 12,000 years ago, at the end of the last ice age, some human groups made a revolutionary discovery. They learned to cultivate plants and domesticate animals. This was the agricultural revolution. It allowed us to produce a surplus of food, which meant we no longer had to constantly wander in search of our next meal. We could settle down in one place, build permanent villages, and support larger populations. This radical shift in our way of life laid the foundation for the next great chapter in our story civilization. The agricultural revolution was the seed from which civilization grew. With a stable food supply, human populations swelled, and villages grew into the world's first cities. Places like Mesopotamia, the Nile Valley, the Indus Valley, and the Yellow River became cradles of civilization. Life in these dense urban centers was radically different. People began to specialize in different jobs. There were farmers, priests, soldiers, merchants, and artisans. This division of labor led to incredible new innovations and a more complex social structure. To manage these growing societies, we needed new tools of organization. We invented governance, laws, and systems of social hierarchy. One of the most profound inventions to emerge from these early cities was writing. Initially developed as a way to keep track of grain and taxes, writing quickly evolved into a powerful medium for recording history, literature, laws, and scientific knowledge. It allowed ideas to be preserved and transmitted across time and space with perfect fidelity. A thought that occurred to a person in ancient Sumer could now be read and understood thousands of years later, on the other side of the world. Writing gave humanity a collective memory. allowing each generation to build upon the knowledge of the last. It was an extension of the human mind, a technology that would change the world forever. With writing came philosophy and abstract thought. In ancient Greece, thinkers like Socrates, Plato, and Aristotle began to ask fundamental questions about the nature of reality, justice, and the good life. They developed logic and reason as tools for understanding the world, shifting the focus from mythological explanations to rational inquiry. In India, the Buddha taught a path to enlightenment, while in China, Confucius developed a system of ethics for social harmony. These philosophical and spiritual traditions provided moral frameworks and a sense of meaning for millions of people. They were grand experiments in how to live together and navigate the complexities of the human condition. These early civilizations were not static. They rose and fell. Empires like the Romans, the Persians, and the Han Dynasty in China expanded their influence through military conquest and trade. They built incredible infrastructure, roads, aqueducts, and great walls that connected vast territories. They created vibrant networks for the exchange of goods, technologies, and ideas. But they also faced challenges: internal corruption, external invasions, and environmental changes. The rise and fall of these great empires is a recurring pattern in human history, a constant cycle of creation and destruction, a testament to both our creative genius and our capacity for conflict. After the fall of the Western Roman Empire, Europe entered a period of fragmentation, but slowly, new ideas began to stir. The Renaissance, beginning in the 14th century, was a rebirth of classical art, literature, and learning. Artists like Leonardo da Vinci and Michelangelo created masterpieces that celebrated human potential, while scholars rediscovered the lost texts of ancient Greece and Rome. This renewed focus on humanism and individual achievement sparked a wave of creativity and intellectual curiosity. It challenged old dogmas and encouraged people to look at the world with fresh eyes, setting the stage for even more radical changes to come. This new spirit of inquiry soon spread to matters of faith. The Protestant Reformation, ignited by Martin Luther in the 16th century, challenged the authority of the Catholic Church and emphasized a more personal relationship with the divine. At the same time, the scientific revolution was fundamentally changing our understanding of the cosmos. Copernicus proposed that the Earth revolved around the Sun, not the other way around. Galileo used the newly invented telescope to provide evidence for this new model. And Isaac Newton developed the laws of motion and universal gravitation, revealing a universe that operated according to predictable, mathematical principles. The cosmos was no longer a realm of mystery, but a machine that could be understood through reason and observation. Fueled by these new scientific ideas, the Age of Enlightenment in the 18th century championed reason, liberty, and individual rights. Thinkers like John Locke, Voltaire, and Jean-Jacques Rousseau argued that governments should derive their power from the consent of the governed. These revolutionary ideas inspired the American and French revolutions, which established new forms of democratic governance and declared that all people possess certain inalienable rights. It was a profound shift in political thought, one that continues to shape our world today. The power of ideas was proving to be just as transformative as the power of armies. This era of intellectual revolution was accompanied by a technological one. Beginning in Great Britain in the late 18th century, the Industrial Revolution harnessed the power of steam and coal to mechanize production. Factories sprang up in cities, drawing millions of people from the countryside in search of work. Railroads and steamships connected the world like never before, accelerating the flow of goods and people. This new industrial power transformed society, creating immense wealth and technological progress, but also leading to new social problems like urban overcrowding, pollution, and harsh working conditions. Humanity had unlocked a new source of power, and we were just beginning to grapple with its consequences. The 20th century began with a sense of optimism, but it quickly descended into the most destructive conflicts in human history. The First and Second World Wars were total wars, mobilizing entire societies and unleashing devastating new technologies of destruction, from machine guns and tanks to aerial bombing and the atomic bomb. These conflicts redrew the map of the world and killed tens of millions of people. In their wake, the world was divided by a new ideological struggle: the Cold War between the United States and the Soviet Union. For decades, humanity lived under the shadow of nuclear annihilation, a terrifying reminder of our newfound power to destroy ourselves completely. But the 20th century was also an era of breathtaking scientific breakthroughs. Albert Einstein's theory of relativity revolutionized our understanding of space, time, and gravity, while quantum mechanics revealed the strange and probabilistic world of subatomic particles. We discovered the structure of DNA, the molecule that carries the genetic instructions for life, unlocking the secrets of heredity. We developed vaccines and antibiotics that conquered ancient diseases and dramatically increased human life expectancy. We walked on the moon, taking our first tentative steps into the cosmic ocean. It was a century of profound dualities, of unprecedented destruction and unprecedented creation. The second half of the century saw the birth of yet another revolution, the digital one. The invention of the transistor in 1947 was the critical spark. It made it possible to build smaller, faster, and cheaper electronic computers. What once filled an entire room could now fit on a small silicon chip. This led to the development of personal computers, the internet, and the World Wide Web. For the first time in history, a global network connected billions of people, allowing for the instantaneous exchange of information and ideas on a scale that was previously unimaginable. Knowledge became democratized, and the world felt smaller and more interconnected than ever before. This digital transformation reshaped every aspect of modern life. It changed how we work, how we communicate, how we learn, and how we entertain ourselves. The global economy became increasingly based on information and data. The rise of the internet created vast new opportunities, but also new challenges, such as concerns over privacy, misinformation, and the digital divide. As the century drew to a close, the pace of change was accelerating exponentially. We were entering a new era, defined not by land or machines, but by the processing power of silicon and the limitless potential of information. The stage was set for the 21st century's greatest technological leap. As we stand here today, on February 7, 2026, we are living in a period of unprecedented acceleration. The digital revolution has given way to the age of artificial intelligence. AI is no longer a concept from science fiction. It is a powerful tool that is already transforming science, medicine, and industry. By 2050, AI is predicted to become an even more integral part of our daily lives, acting as personal assistants, medical diagnosticians, scientific researchers, and creative partners. The rise of advanced general AI could solve some of humanity's greatest challenges, from curing diseases to developing clean energy. But it also raises profound questions about the future of work, ethics, and even what it means to be human. At the same time, we are beginning to merge our biology with our technology. Brain-computer interfaces, once theoretical, are now allowing people with paralysis to control robotic limbs with their thoughts. By 2050, these technologies could become more widespread, offering to enhance human memory, intelligence, and communication. Imagine being able to access information from the internet with a single thought. This convergence of mind and machine holds incredible promise, but also carries significant risks. It forces us to confront difficult questions about identity, equality, and the very nature of consciousness. Will these enhancements be available to everyone, or will they create a new divide in society? Our gaze is also turning outward, back to the stars. Commercial space companies are making access to orbit cheaper and more frequent. Ambitious plans are underway for permanent bases on the moon and the first human missions to Mars. By 2050, it's plausible that small, self-sustaining human outposts will exist beyond Earth. Becoming a multi-planetary species would be a monumental achievement, a backup plan for humanity in case of a catastrophe on our homeworld. But it also presents immense logistical, ethical, and psychological challenges. How will we govern these new societies? And what will it mean for our human identity when some of us are no longer Earthlings? The rapid pace of technological change is also reshaping our societies, economies, and belief systems. Global power dynamics are shifting, and the nature of work is being redefined by automation and AI. We face immense challenges, from climate change and resource scarcity to political polarization and the erosion of shared truths. Yet, we also have more powerful tools than ever to address these problems. The coming decades will be a test of our wisdom and our will. Can we navigate this complex future with foresight and compassion? Our journey from the Big Bang has brought us to this critical juncture. We are the authors of the next chapter, and the story of what comes next is waiting to be written.